In this paper, we outline a methodical approach to optimizing the processing of documents for natural language processing models. The first step involves segmenting each document into chunks that adhere to the maximum sequence length allowed by the model. This segmentation ensures that the input constraints of the model are respected, setting the foundation for efficient processing. Following the segmentation, our algorithm intelligently selects a subset of document chunks that collectively fill up the fixed sequence length without breaking any individual chunks. In cases where the selected chunks do not completely occupy the sequence length, padding tokens are strategically employed to maintain the integrity of the original chunks while completing the sequence. Scalability and speed are crucial considerations in handling large datasets. Our algorithm is designed to scale linearly with the dataset size, enabling the processing of substantial amounts of data without compromising on efficiency. By formulating the process as a combinatorial optimization problem, we aim to pack document chunks into training sequences with minimal truncation and padding, optimizing the use of available context. Empirical validation on large-scale pre-training datasets showcases the effectiveness of our best-fit packing algorithm in reducing truncation and enhancing training efficiency. Comparisons with traditional concatenation methods highlight the algorithm's ability to minimize the use of padding tokens while maintaining training efficacy. Through our analysis, we demonstrate how best-fit packing effectively reduces truncation, particularly for shorter documents, while preserving the integrity of the majority of documents by truncating only when necessary.